Hey there, future scientists. I'm David Monk, after-school STEAM educator with Fort Bend Children's Discovery Center, coming at you with another live event right here in our Kidtropolis gallery. Thank you guys so much for joining me today. In a few moments, we're going to do some activities that help explore the weather. Before we do that, we want to give a big shout out to our funder at the Fred and Mabel R. Parks Foundation. Without you guys' help, we wouldn't be able to be here today to inspire the future scientists of not only America, but the entire world. So thank you guys so much for what you do. Like I said, today we're going to investigate the weather. We're going to be making some instruments that can calculate and actually measure the type of weather that's going on. I'm going to get more into that here in a moment. Per usual, I've got my outline here, so I just don't want to forget anything as we go through our Facebook Live event. I make sure I'm passing the best scientific knowledge that I possibly can to you guys out there that are watching today. Thank you so much for joining me. So first, I want to give you some time to set up and get your materials ready. And momentarily, I will go over all the materials that you need. Before we do that, let's kind of talk about what's going on in your weather today. We have viewers from all over the world. So if your weather is nice and sunny today, go ahead and throw one of those heart emojis in there. Let's say it's not so nice and sunny. Let's say it's like Houston's weather today. It's cloudy, it's windy, it's rainy. Go ahead and give me a thumbs up if that's the type of weather you're having. And let's say that you're from a bit farther north than Houston and you're getting some cold, maybe some snow, some sleet, something like that. Go ahead and throw a heart emoji at me. So it looks like we got a lot of sunny weather out there. That's good. We're not so fortunate today, but that's awesome to see that you guys have got some terrific weather going on, okay? So today I'm going to make two scientific instruments that measure weather conditions, okay? So we're going to be looking at winds, and we're going to be looking at pressure systems, and we're going to talk about what those things mean. And the only reason I'm bringing that up is because one of our viewers actually sent us a letter and asked us a question. So I want to put this out to you guys right now. If you want to reach out to us, you have questions, comments, concerns, you want to show off the things that you made, just email us at geeks, that's Geeks, at cmhouston.org. Again, that's geeks, Geeks, at cmhouston.org. And you never know, we might spotlight your question, we might do an entire investigation just around what you guys asked. And also I want to say, I'm a human being, so I'm not perfect. I make mistakes sometimes. So I would also really like if I say something that is incorrect, send us an email. We want to know where we misspoke, and then we can come back for another live event, and then we can talk about that and kind of go over that stuff. But generally, we're locked on with our science. So without further ado, let's go ahead and get rolling into our investigations today. We've got two, technically three. What I'm going to do is first I'm going to go over the material list. And before that, so I have a letter, and this letter is from Jax in Slidell, Louisiana. And he wants to know, he says, when I watch the news, they always mention high and low pressure systems. What's the difference between the two? That's a terrific question, Jax. A lot of people see that on the news, but they don't necessarily understand what it means. So today we're going to look at that very closely. So the next time you watch the Weather Channel, you'll know exactly what a high pressure and a low pressure system is. And it's all about the wind and the temperature and all that stuff all revolves around highs and low pressures. So let's go over our materials. So the first activity that we're going to do today is called an anemometer. So an anemometer actually measures wind speed and wind direction. Our anemometer is only going to show the wind direction, but it's very simple to create an anemometer that will actually show you the wind speed. And I'll kind of talk about that once we get going. But we don't have a whole lot of time today, so we want to get moving here. So the materials that you need for your anemometer are going to be paper plates or bowls. I kind of like the bowls. They're just a little bit more sturdy, a little bit better of an engineering structure to use for this. But in the end, I'll show you I made one out of paper plates as well. These are actually styrofoam, so that also works. Just remember, whatever you're making, particularly for the anemometer, it needs to go outside. So you don't want to have an anemometer inside, because the only way you'll see wind direction is if you bring a fan or you blow on it, right? So you want to see what the weather's doing, not what the artificial weather is that you created inside the house. So I've got some styrofoam bowls, some extra materials just in case I mess up. I tend to do that. Also, you need a pencil, and the important part of the pencil is you need to have the eraser. So make sure the eraser is intact, okay? So we've got a pencil. Tacks are push pins. So I've got a couple of push pins here. There's so many different ways that you guys can make this. So if you don't have this and you use a different material, it'll be completely okay. Just use what you got. Also, you're going to need a straw. So I've got my straw here with me. You're going to need a marker. I'm going to use a Sharpie today. Feel free to decorate it, add your art touch to the steam projects. Don't forget about the art and steam, right? Tape. So I've got two kinds. I've got some masking tape, and then I've also got some sellotape, clear tape, or also known as scotch tape. And then you'll want to have a Weathervane printout. So you guys might not have this at home, and if you would like it, again, email us at geeks@cmhouston.org, and we'll actually send you the document you need. But this is not necessarily crucial to have, because you can actually just make these pieces out of other materials that you have at home. A great one would be cardboard. What I'll say about this is don't use printer paper or anything flimsy. It needs to have, a little bit, needs to be a little solid, so the wind will actually catch it and move it. Because if it's too flimsy, it'll just blow the paper back and forth, and you won't actually have an anemometer. So again, if you guys want this, just let us know. We'll send it out to you. If you're doing this with me right now, if you don't have it, no big deal. Cardboard will work perfectly fine, or any other material that you have around the house. All right, so after we do our anemometer, we're going to do a barometer. So a barometer measures atmospheric pressure, those highs and lows that Jack's asked us about. So you'll need a tin can. Be careful when you take the top off, because remember there's very sharp edges here, so careful when you're working with your barometer. We don't want you guys to cut yourself, right? So we've got a tin can. We need a rubber band or tape. I'm doing both because I want this to be a sturdy structure that lasts for a while, but if you just have one or the other, it'll be perfectly fine. So we have a rubber band or some tape. Paper clip. This is a pretty important material, so make sure you have your paper clip, a straw, a balloon, and I'll show you what I've done with the balloon. So this one is intact, right? But what you actually need to do is cut the end off of your balloon. So you can see like that. And I'll show you why, but you want to make sure you cut the end off. So you need some scissors as well today, if I didn't mention that already. Hot glue, that's kind of optional. I'll show you what I did with the hot glue later on in this investigation, but if you don't have that, don't freak out. You're going to be good to go today. A marker again. I've got my Sharpie. And then the last thing that you're going to need for our last investigation, which I'm not actually going to create, I'm just going to show you guys, it's super simple, is the rain gauge. You're going to need an empty water bottle, which I have here, and I'll kind of talk about how this all comes together. You'll need some scissors, some tape, gravel, sand, or sand, and a ruler, all right? And then I also have this chopstick here, which I'll talk about. You can use a skewer, you can use a stick, you can use so many different things. It does not have to be a chopstick, but I'll talk about why this is important as we get on to our investigation. So, not a lot of time today, so we're just gonna hop right into it. So the first thing we're gonna create is our anemometer. So for your anemometer, you're gonna need 2 of your bowls or paper plates. And remember, so we're creating a very quick weather instrument today. If you guys make something that's more durable, because these things do go outside, please send that to us, and we'd love to show you guys off. All right, so you're gonna take your 2 paper plates, all right, and you wanna put them one on top of the other, just like so, okay? And honestly, if you have more than 1 paper plate, it might be a little bit sturdy if you use more than 1. Today, I'm just gonna use the 2. I like to, conserve as many materials as possible and take care of our wonderful earth. So I'm just gonna use 2. But remember, you're gonna make this to last, so if you use more, it's totally okay. All right, so you take your paper bowls, your paper plates, and you stack them on top of one another, just like so. All right, and the first step is you're gonna wanna take some tape. So I've got my sellotape. Again, you can use masking tape, duct tape, electrical tape, whatever. It doesn't really matter, just as long as it's something that's gonna adhere to the surface and keep these 2 bowls together, or plates. So I'm just gonna put a few pieces of tape. You don't really have to go too crazy on it, but again, if you're gonna make this outside, durability is important because it's actually gonna be in the weather. There's gonna be wind, rains, depending on where you're from, snow, sleet, all that stuff. So I'm just gonna put a few pieces all the way around their bowls here. And remember, we're creating our anemometer. And our anemometer is gonna show us wind direction, and then if you make an advanced one, wind speed. So for ours today, we're just gonna show our wind direction. All right, so I should have plenty of tape on there. I did just skip a step, and I wanna mention it because it's pretty important. One thing that you wanna put on the inside is here, something that's gonna weight this down. Because remember, it's gonna be in the wind. Its job is to measure wind direction or even wind speed. So you're going to want to put stuff in here that is actually going to keep it from blowing away when the wind does start to blow, right? Otherwise, you won't get the observations that you're trying to get from the weather. So you can see I've got it all taped up around the edges. I just used a few pieces here and there. Like I said, you guys make this your own, make it how you ever want. Just because I do it a certain way does not mean that's the only way to do it. So now that we've got basically the base, remember, put something heavy inside. The next thing you're going to do is, I brought a pencil that's sharpened, and I've done that for a reason today, is because I'm actually going to use it to poke a hole in about the center. It does not have to be perfect, but about as close to the center as possible. And then this is actually an important step. You want to spin it a little bit. All right, and this is just giving it a little bit more space, because remember, this is where your anemometer is actually going to spin and show the wind direction. So you don't want it to have too much friction and actually stick to whatever vessel you decided to use today. All right, so that should be perfectly fine. All right, so now I'm going to take my pencil. Remember, most important part really needs to have that eraser. This is the functionality of this anemometer here, and I'm just going to put it in that hole that I made. Now, this pencil is actually a little bit bigger than the other one, so I'm going to do the same thing just a little bit. Just kind of give it a little more space, reduce that amount of friction, and if you poke all the way through the other side, it's fine. It should work just as good. Just make sure you're doing the same thing that I'm doing right here. Just trying to widen that hole a little bit. All right. So I want to make sure this really spins, so I'm going to do that just for a couple more seconds. All right. So now that we've inserted our pencil, the next thing you're going to need is you're going to want to get your Weathervane pieces. It doesn't have to be an arrow like this. You can see all kinds of decorative ones. I know the famous, well, not famous, but a popular one is a rooster. You just need to know which direction is pointing towards the certain north, south, east, west, right? So whatever cardinal direction, you want to know what it's pointing at, so you make sure it's not backwards, right? So I'm going to cut these out very quickly. All kinds of stuff that you guys can use for this, but you want to take into account it doesn't want to be too heavy, because then that might actually weigh down your anemometer and it will not function the way you want it. Right? So this is going to be the piece in the rear, so this is the front. This is going to be our indicator piece that points to the direction, right? And this is just going to actually help catch more wind. So yes, we're measuring wind speed, but we're also looking at wind direction. So we need to have something with enough surface area that it's actually going to catch the wind, right? So if you made something super small, it's not going to have a whole lot of surface area. It's not going to be able to catch the wind, and your anemometer will not function properly. Remember, you haven't failed. You learned something, so then just go back, remake your anemometer, and then you'll make it bigger, it'll work better. So problem solving, that's a big part of the scientist, and meteorologists as well, but you're definitely scientists. Okay, so the next you're going to need your straw. And what I'm going to do is I'm going to take my straw and I'm going to cut it right down the center on the end there. Not too far, and I want to do this on both sides. So I like to put the piece in first, that way I'm not putting them in wonky and one's going in one direction and one in the other. And then I even recommend, most especially since this is going to go outside, go ahead and use some tape and secure it on there, right? Because if these blow off, then that's a big part of the functionality for your anemometer. You don't want that to happen. So you want to make sure that once the wind does start to blow, that it actually stays on your straw. Right? So that's good. Got that one. Not going anywhere, right? All right, so now I'm going to do the same thing for the other end of the straw. I'm going to take my scissors. And remember, if you are our younger scientists out there, make sure that your parents are helping you, especially with the things like the push pin and the scissors, just to stay safe. I want you guys to have a great time, but we don't want you to have to put a Band-Aid on at the end of this investigation, right? So now that I've got my little cut in my straw, actually put it on backwards. All right. So that's more or less how it should look. Remember, you can make it out of so many different things, and if you want the printout, we'll send it your way. That's basically how it looks. So I'm going to go ahead and use a little bit of tape here to secure it at the ends. I'm going to flip it over and do one more. So remember, anemometer, that's measuring wind speed and wind direction. So the wind speed part. Now you can make some things that are very technical and actually tell you the actual miles per hour. That would be an investigation you have to dig really deep into. But you could also get one of those little pinwheels, or even like a propeller. You can make it out of paper or all kinds of stuff. And you won't be able to tell the exact miles per hour of the wind, or kilometers per hour, depending on where you live. But you will be able to look out the window. You'll be able to tell the direction of the wind, and then you can look and see if it's spinning, right? If it's spinning fast, oh wow, it's super windy outside. Let's say it's not spinning at all, then you know, no wind. So it's still a great instrument, even if it's not super technical and doesn't tell you the exact specifics. So one of the last steps, it's not the last step. We're gonna take our piece here for our Weathervane, and we're gonna take the push pin, and we're gonna go about the center. And if you're off a little bit, again, it doesn't really matter. And I'm gonna poke it right through the straw. Remember, young scientists out there, make sure you get help for stuff like this. All right, so there we go. So it's almost done, but what you'll notice is right now I just have an arrow, and we wanna know what direction, what cardinal direction is the wind actually blowing, north, south, east, west. So what you'll do is you'll take your marker or your Sharpie and you'll label it. So I'm gonna go ahead and put my north, my south, my east, and my west. Okay, so it's almost done. But do you have an internal compass? We all kind of do, but could you just look out the window and know what's north or south without actually knowing where you're at? Probably the answer to that is no. So what you want, the last thing you want to need is a compass. So you're going to take your anemometer, you're going to take your compass, and you're going to line it up. So say if I'm pointing it here, this direction is north, I would take my anemometer and I would make sure the end is facing in this direction, which is going to be north. So the compass is very important for this. You can just make it without this, but you're losing a lot of like the technical details about the weather, which is something very important. Especially for people that need to go work outside. They want to know if the wind's howling, they want to know if it's raining, they definitely want to know if it's ice and snow and sleet, stuff like that. So I'll kind of show you, make sure we got this. All right, I think it's about ready. So I'm going to go ahead and give it a little artificial test because we have to do this indoors. Like I said, today the weather in Houston is not wonderful, but let's see if it works. So you guys can see, as the wind blows, it catches the surface area of the cardstock or whatever material you chose to use, and actually pushes your anemometer into the direction that the wind is blowing. So this is super simple, and this is actually an instrument that could be very helpful. I mean, flying kites, all kinds of stuff revolve around the wind, right? Maybe just what you're going to wear that day. If you look outside and it's not moved and it's not spinning, you probably don't have to wear too many warming layers depending on the temperature. But if you do look outside and you see this just blowing away, you'll know to prepare for that. So this is a wonderful instrument, and it took it just a couple of minutes to make this. This is legit, guys. Like I said, you can definitely take this deeper. We do geeks@houston.org. We'd love to see that. We'd love to talk to you about it, all that stuff. So that's our anemometer. That's our first weather instrument that we're going to make today. We're going to have 3 in the end. Technically, this is a weather station, and you guys can see I made one earlier, and I made it out of paper plates, or styrofoam plates, excuse me. So if you don't have that, remember, the paper plates will work. I just think this is a little bit more sturdy and better for the purposes that it's going to serve. But if this is all you have, feel free to use this, guys. And if you have other materials, use that as well. It's no big deal. As long as you get the accomplished task here, which is wind direction, right? Then it's good to go. It's good to go. All right, so that is our anemometer. So remember, anemometer, we're looking at wind speed, and we're looking at wind direction. All right, so Jax, thank you again so much for your letter, but I want to tell you that I know I didn't necessarily answer your question because I talked about the wind, but that ties into highs and low pressures. So the next instrument we're going to make is called a barometer. A barometer measures atmospheric pressure. So we like to think about forces, push and pull, right? And when you ask somebody, hey, what force are you under on Earth? You generally get the same answer. Oh, just a pull, right? Gravity is pulling us to the center of the Earth. But that's actually not true. There's 2 forces that work upon us. There's gravity, and which is our pull, and there is a push. So look around your room. You probably see nothing, right? Well, that's because we're talking about the gases in the room. And believe it or not, those gases are actually pushing on your body. Super important for you to have this because it keeps our bodies actually in the form that it is and we don't come apart, right? So the first thing you're going to want to do is you're going to get your tin can. Again, be very careful around the edges there. And you're going to take your balloon and you're gonna open it up. I brought extras because the balloons tend to tear from time to time. So you might want to have a couple on deck just in case. And you really want to make sure that it is as flat on the can as possible, right? So inside of here, I've trapped some air. So there's air pressure inside the can. But that's not the only air pressure. There's also air pressure that's also pushing on the can. And that's essentially how all barometers, and even this little simple one, works, right? So I'm gonna push this down just a little bit more. And remember, make it as sturdy as possible. Now the cool thing about a barometer, you don't necessarily have to be outside. You don't have to be outside at all, actually. You can actually just use your barometer indoors. So for this one, it doesn't have to be as sturdy, but I like to keep them all together. Ideally, I would take all of these and mount them on some sort of platform. So I could look out the window, I'd probably have a thermometer, I'd have my rain gauge, my anemometer, my barometer, and I just look in one specific place, and then I know all these different things about the weather. So I've got that on there pretty secure. All right, so again, I want it to be sturdy, even though we're indoors. I want it to last, right? I don't want to have to keep making a barometer every time the wind changes or the temperature or anything like that. So, I'm going to go ahead and do this. And something I didn't mention before is wind is created by the uneven heating of the Earth's surface. So we have land masses and we have water masses. And the sun's radiation does not heat them up evenly, all right? So that's actually what creates wind. So wind ties into barometric pressure as well. So a low pressure system is a low pressure at its center, and the wind tends to blow towards it. So if you're in the middle of a low pressure, you're going to have these winds that are blowing towards you. High pressure is just the opposite, where it's a high pressure in the center of the system, and the winds actually blow away from the center. So if you know that, you can almost say, oh, I know kind of which way the direction is going to blow, depending on where you're at, where you're located. But if you have that knowledge, you'll know it's either coming towards me or blowing away from me, depending on the system, right? So I've got my tin can and my balloon secured on the top. And this is such a super simple activity here. Actually, I'm going to have to use one of the straws here because I forgot to bring an extra one. But adapt and overcome, right? Problem solved. So I already have an anemometer, so it's okay that we're sacrificing this one today. So you're going to take your straw and you want to put it on the ends, right? So it's going to want to come all the way to the very edge there, and then you're going to take a couple of pieces of tape and you're going to want to secure it to the top, and I'll show you here in just a second. So I have it on there. So I'm going to use one here, and then one more piece here. So, believe it or not, I know this looks super simple, and you might just say, hey, you did not make a weather instrument, you made a piece of trash. You would not believe how accurate this is, and I'll talk about how to set it up here in a moment. But this is a barometer. This is really all you need. You need a way to measure it. We're going to talk about that in a second. But pretty much your barometer's done. Think about that. It took a minute, right? And it's just very cheap materials that you can find around the house. So that's super cool. So let's go ahead and talk about how to measure, right? Because right now we just have a straw that's taped to a tin can. So if I'm just looking at this, it doesn't tell me anything, right? So you need a way to measure it. Now the simplest way is take your barometer and put it outside, okay? And then what you want to do is take a stick or a skewer, I'm using a chopstick, right? And you want to stick it in the ground and make sure the straw is pointing there. And actually, I skipped over a step here. It's not done. Sorry guys, we forgot something here. You want to use this paper clip, and this is going to just give you a more precise measurement. So what I'm doing is I'm just kind of unfolding it, and I'm going to take this end piece here and kind of mash it in, and then I want to place it inside of my straw. I got ahead of myself. This is actually very important. It doesn't have to be super straight. It's all about how you set up the measurement system, but something like that should work beautifully. So now that you have this, because you can see this is less surface area, it's more precise on where it's pointing instead of just a straw. But honestly, just a straw would work as well. This is just helping to make it a little bit more accurate. So you're going to take your stick or your skewer or whatever it is that you guys come up with, stick it in the ground, and then what you have to do is is you have to think about what is the weather like today. So I know that today here in Houston, the wind's blowing a little bit, it's rainy, it's cloudy. So we have that background knowledge. We know that that means there's a low pressure system, okay? So knowing that, I would take my Sharpie and I would make some marks. And the first mark, you want to indicate somehow, right? Maybe you're using something a little bit bigger, but I would just put an L, and I'll show you this in a moment. I'm just drawing an L there because I already know that the pressure that's set up on this can is going to be a low pressure, right? So I put a few more ticks below because just because the pressure is low right now doesn't mean it's as low as it will get. So I'll put a few more. And it's really good to use a ruler for this, but since it's not super accurate, you don't necessarily have to do that. But as a scientist, remember, try to make these things as precise as possible. So I would definitely pull your ruler out, yardstick, tape measure, whatever you have. So we know that right here, where it's going to point, that's going to be a low, right? And anything below that is going to be a low. And then I'll add a few more marks. And up top, I'll put an H for a high pressure system. So as the pressure changes outside the can, it's going to move the straw and the paper clip up and down according to the pressure. So if it's a high pressure, it'll actually move up. And if it's a low pressure, it'll actually move down. Now it might not be that dramatic, but it will show you the difference in the pressure. And I've got another one that I've created before, and I created it on a nice sunshiny day. So let's go ahead and pull that one out. And I want to see, is it actually working, or do I just have a tin can with balloon stuff on it, right? So what I've done, this is a different way you can do it. So if you're going to do it indoors, I've just taken some cardboard. I used some hot glue, some tape, and things like that. I used a black card or construction paper on the back just so this shows a little bit better. And then I just found these images online and I printed them out in Word, right? And then so I have basically my medium here between high and low pressure. Anything that's here and above, we should be looking at fair weather, and anything that's below here should be a low pressure. So we're looking at, maybe not the greatest weather that day. So it's all dependent on how high and how low the pressure is according to the weather. And then I've also created this. You can see this is just a little stand that I made to help it set up, and I've just used pieces of cardboard. Again, if this is not how you want to make yours, there's so many, you can just lean it up against something and it will work perfectly fine. All right, so this is just what I've chosen to do. So I'm going to take my little measurement board here, and then I'm going to take my can and, oh, actually, hold on. It's important that you know where you put it. So when I made this one, it was actually, I drew the line, but my can was way down below, right? So what I did is I just took an old coffee cup and then reused it, right? Reduce, recycle, and I just taped it so it would point to the zero, and you guys can actually see it's just below the zero. And on the day that I made this, it was pointing directly at the zero. So this works. It's not super, super precise, but if for some reason I couldn't look outside, I could look at this and I could tell you, hey, the sun's probably shining today, or I could tell you, hey, it's probably nasty weather. So either go to the beach or don't go to the beach, right? So this could be your go to the beach indicator as well, if you don't want to call it a barometer. But it's just super cool that this, just such a simple materials and stuff like that, actually plays a great scientific role in teaching you, but also being able to actually measure the weather. So what meteorologists do, they're scientists that investigate the weather. So next time you watch the news or the Weather Channel and they bring that big H out, right? You know that's going to be a high pressure. Or they bring that big blue L out, you know that's going to be a low pressure, and you'll know, hey, it's a big blue L today. It's going to be raining, it's going to be windy, right? Or if it's the big H, you'll know, hey, let's go to the beach, or hopefully, because the temperature is a little bit different. Now remember, that's something you can add as well. I haven't done that today, but you can also add a thermometer, another great indicator or a way to measure weather, right? And put that on your weather station as well. So ideally, I would take all these things that I made, other things that measure the weather, and put them all in one place like I told you before, right? So it's very simple to make. Like I said, you don't have to do it like this. You can just draw the sun, you can draw a cloud, you can write high, you can write low. However you choose to measure it, just as long as you understand what the indications mean when your little paperclip points to a certain area. So that is our barometer and our anemometer, and you guys can see it just took a few minutes, and already, if you guys are doing this with me, you're set up to investigate the weather. So go ahead and do that for me. When we're all said and done, go ahead and set your instruments out, take some pictures, send it to us, geeks@cnhouston.org. We'd love to see it. And remember, you got any questions or future things that you want us to talk about it, throw it at us. You never know, we might spotlight whatever science or activity that you want to investigate. Okay, so I'm not quite done. So for this last activity, which is actually already completed for me, and I'm going to give a big shout out to my fellow geek, John. He is actually a big time in the meteorology. So I'm still in his thunder a little bit, Dave. Sorry, John, but thank you so much for providing these materials. And I'll show you, all you need is an empty water bottle, some tape, and you're going to cut the top off. Basically where it starts to round and gets a little flat, that's about where you cut it, all right? So once you've removed the top, you're going to take some rocks or some sand or really anything that's going to weigh this down. Because remember, the rain gauge is worthless inside. If it's raining inside your house, you got bigger problems, right? So you want to put something in here that's actually going to weigh it to the ground. Ideally, you actually want to have something that'll attach it to the ground. Because remember, weather, especially here in Houston, hurricanes and stuff like that, they can get super nasty and easily blow this stuff over. So I've got my rocks in there. Once you have your rocks, you're going to put a little bit of water as well, and you're going to draw a line. It's going to be your baseline. It's going to be 0. All right, so if there's nothing above 0, let me show that to you guys, then you've had no rain accumulation for that day, okay? Always a good idea to write down what your accumulation is. So if you guys got your scientific journals, this is a great activity to do that. And so what we've done, or what John shows me to do here, is he's actually measured it in centimeters. You don't necessarily have to do that. You can do inches. I know a lot of time in the United States, we like to measure via inches, but centimeters is perfectly fine. And here you really do want to have a ruler because you want to have an accurate gauge to how much rain is falling. So all the rain that's falling all around us, it's also going to go in here. So this is a pretty accurate way to know how much rain is falling all in your vicinity. It's not just going to rain on top of this cup, right? It's going to be all over the place. So this is our rain gauge, yet another super simple weather tool that you can make on your own at home with just very limited materials. So just think about it. We've got some pretty cool stuff. We've got a barometer, we've got our rain gauge, and we've got an anemometer. And you can add so many other things to this and just make it as elaborate as you possibly want. If you're really into the weather, just go online, send us an email like I said, and we'll tell you some other things to add. Some of them I've already mentioned today. So again, big shout out to John. Thank you, John, for providing these materials. He actually gave us this this rain gauge as well. So this is one that you can actually buy online, and you can see this one I believe is in inches. Yeah, so you can see this one is actually in inches. It's a bit sturdy, right? So you don't really have to worry about blowing away. You can attach them to things. Popular place. I'm a big gardener. So a really good place that you want to keep these if you're a gardener is in your garden, because then you'll be like, hey, do I need to water the plants today? You just look here, oh, I've got 3 inches of rain. No, we don't want to drown our poor little plants. Or the opposite, right? You look, we've had no rainfall today, time to get out there and water the plants. So it's also got things on the back, you can attach it to all sorts of stuff. So that is our barometer, anemometer, and our rain gauge. Again, guys, we want to thank the Fred and Mabel R. Parks Foundation for making this live event possible. You guys are awesome. Please send us questions, comments, concerns at geeks@cnhouston.org. Again, I'm David Monk, after-school STEAM educator, coming at you right here, Fort Bend Children's Discovery Center and our Kidtropolis Gallery. Love seeing you guys. Can't wait to see you next time. And David Monk, signing out.